This video will show you how to convert complex number from rectangular to polar or trigonometric form. Okay, let's recall the complex plane in which complex number is being represented. So remember that the horizontal or x-axis is the real axis, the vertical or y-axis is the imaginary axis. So the complex number in rectangular form is given by z equals x plus I y. Now, as you can see, we have theta and r in this complex plane. So this will help us understand the polar form of a complex number. Now, as you can see, this complex number in rectangular form can be replaced by a function, a trigonometric function, where x is equal to r cosine theta, y equals r sine theta. So the question is, how did we arrive into this equivalent? So going back to this complex plane, we know that this side of the triangle, okay, so as you can see, we have a triangle here, a right triangle. So this side is the adjacent side of the angle theta, and this is the opposite side of the angle theta. And the hypotenuse is denoted by letter r, or the absolute value of the complex number z. Now, if you get cosine theta, so cosine theta means adjacent side over the hypotenuse side. Okay, so adjacent is x, hypotenuse is r. Therefore, x is equal to r cosine theta by multiplying both sides of the equation by r. Now, for this opposite side, if you take sine theta, so sine theta means opposite over the opposite over hypotenuse. So this is y over r. Okay, so multiplying both sides by r, we get y equals r sine theta. Now that we have the equivalent of x and y in trigonometric form, we plug it in here in z equals x plus iy. We can write z equals r cosine theta plus, and in this case, r is already factored out, so plus I sine theta. Or you can write the trigo form of complex number z equals r cis theta. Cis means cosine theta plus I sine theta. Or you can write z equals the absolute value or the modulus r argument theta. So this is in polar form. So how do we determine r and theta? Okay, so the modulus or absolute value of a complex number, okay, referring to the triangle, you can say that r, the hypotenuse or the absolute value, okay, by using the Pythagorean theorem, we can determine by taking the square root of the sum of the squares of the real numbers. So in this case, x squared plus y squared. Again, so we use Pythagorean theorem to determine the absolute value or the modulus of the complex number. Now, the argument or amplitude of a complex number can be determined using this formula. So if you go back to the previous slide, tangent of theta is equal to the opposite, which is y, and the adjacent, which is x. So taking the arctangent, we get theta equals arctangent of y over x. So again, theta is the argument or amplitude of a complex number. Example number 1, express the complex number 1 plus I squared root of 3 in polar form. So the given is in rectangular form. Now, must be clear, or it should be clear that x is 1 and y is squared root of 3 in this complex number. So by using the formula in finding for the absolute value, so we have square root of x squared plus y squared. So the absolute value or the modulus is equal to 2. So this is needed for us to form the polar complex number. Now for theta, we use arctangent of y over x. So y is square root of 3 and x is 1. So arctangent of square root of 3 over 1 is 60 degrees. That's why the complex number in polar form is 2 cis 60 or 2 argument 60 degrees. Example number 2. Write the complex number 4 cosine 225 plus I sine 225. Again, 4 here is factored out. So we should write it in rectangular or standard form. Now we use our calculator to determine the value of cosine 225 and sine 225, and their values are equal. So cosine 225 is equal to negative square root of 2 over 2, and sine 225 has the same value. Okay, negative square root of 2 over 2. Now we plug it in here. We have 4 times the quantity negative square root of 2 over 2 plus I times the quantity negative square root of 2 over 2. So distributing 4 in each term. So 4 divided by negative 2. So we have negative 2 square root of 2 minus 2 square root of 2i. So this is now the rectangular form of the given complex number. Example number 3. Find the magnitude or modulus in the argument of the complex numbers in factored form. So 4 plus 7i times 3 minus 2i. The first thing that we need to do is to determine the product. Okay, so we can use the formula or the technique that I have explained to you or discussed to you in the previous meeting. So here, 4 times 3 is 12. 7i times negative 2i will give us negative 14i squared. So I squared is equal to negative 1. That's why we have positive 14. So here, 3 times 7i is 21i. Negative 2i times 4 is negative 8i. That's why we have 26 plus 13i as a result to multiplying these complex numbers. Now that we have this result, we can determine the modulus. So we use the formula square root of x squared plus y squared. That's why we have 26 squared plus 13 squared. And take the square root, so the answer is 29.1 is the modulus or the magnitude or the absolute value of the complex number. Now for theta, so we get the arctangent of 13 over 26, or the arctangent of 1/2, which is 26.57 degrees. So this is the argument or the amplitude of the complex number. Now, how do we multiply our complex numbers in polar form? So we simply multiply their absolute values or their modulus, and then we add the arguments or the amplitude. Okay, so multiply again. Okay, this is in trigonometric form, and this one is in polar form. So actually, polar is the same with trigonometric form. Now, for division of complex numbers in polar form, we divide the absolute values or the modulus, and then we subtract their arguments. So that's it. Let's have this example. Multiply these complex numbers. Okay, let me just write some correction here. It should not be cis, but it should be cosine 30. Okay, so this should be cosine 30. This is cosine 60. So in multiplying complex numbers in polar form, we multiply their modulus or their absolute values, and then we add their arguments. Okay, that's why we have this result. So let z sub 1 be the first complex number in polar form or in trigonometric form, and z sub 2 be the complex number, the other complex number. So we're multiplying, so the absolute values we have 8. So 4 times 2 is 8, and then we add their arguments. So 30 plus 60 is 90. Or you can say 8 cis 90. Okay, so let me just erase this one. Now we divide complex numbers. In dividing complex numbers in polar form, so we divide their absolute values and then we subtract. Okay, in this case, so 540 minus 225, we subtract their arguments. So we have 4 cis 315. So if you're not asked to represent your answer into polar form. So your answer should be in rectangular or standard form. That's why we have this answer 2 square root of 2 minus 2 square root of 2i, since cosine of 315 degrees is 1 over square root of 2, and sine 315 is negative 1 over square root of 2. Okay, so before I end this video, so please take note of the given, because you will be answering these 4 questions. Okay, so given z sub 1 equals 2 plus 4i, and z sub 2 equals 3 minus 5i. Again, the given are in rectangular form. So you determine the modulus of the first complex number z sub 1. Number 2, determine the argument of z sub 2. Number 3, the absolute value of z sub 2. And number 4, the absolute value of z sub 1 times z sub 2. Good luck!